We've talked about absolute value. We've talked about inequalities. Today we're going to talk about absolute value inequalities. We're going to put those two ideas together. So that's what we're talking about in section 9.3. So absolute value inequalities. Let's look at a real simple one to kind of get the idea of this, and then of course, like we always do, we're going to build this up and try to do some more advanced problems in a little while. So let's go ahead and let's graph, and I'll explain absolute value of x less than 4. Now, what I'd like to do, I want to start off by thinking about some of the numbers that are in this set. We all know what absolute value does, right? Absolute value makes anything that you put in there positive. If it is positive, it remains positive. If it's negative, it becomes positive. Can you give me a number that satisfies this expression, this inequality?
1.
1 satisfies it. Great. 1, absolute value of 1 is 1. Is that less than 4?
Mm-hmm.
Give me another one.
-2.
-2. Why -2?
It's still less than 4.
Sure, okay. How about, what else? Say that again. -4. How about -4?
No,
Well, why not?
because it's going to turn positive and it doesn't have any.
Oh, so if I put in -4, absolute value of -4 is
4.
4 strictly less than 4?
No.
No. So that would not work. Give me another one that does work.
3.9999
Negative
negative.
3.999999999 forever. Absolute value of negative 3.999, that's supposed to be 999, forever is positive 3.9999999 forever. Is that less than 4?
Yes.
Then yes, that would work. 3.99999 forever would work, because absolute value of that is still positive. How about 4? Would 4 work?
No.
No, because absolute value of 4 is 4, that's not less than 4. How many people understand that what these numbers look like? So if we were to do this on a number line, I can't plug anything in greater than 4. Because that seriously would be greater than 4, right, in absolute value. Here's 0. But I also can't plug anything less than -4. The reason is, if I plug in anything less than or equal to -4, in absolute value that changes it to a positive, which then becomes bigger than 4. Are you with me on this, ladies and gentlemen? So when I graph this, what this is I'm going to use parentheses to signify that this is open. What we're talking about is this range of numbers in here. Anything between -4 and 4, but not inclusive. The reason why it's not inclusive is why? Why is it not inclusive? Yeah, there's no equal sign up there. Very good. Let's see if we can take this and run with it. Hey, when we first started dealing with absolute value, how many equations did you get with absolute value? No matter what, you get 2, right? Hopefully on your homework you got 2 in every single case. I hope you did that. You're supposed to get 2 in every single case. Well, if we get 2 equations when we're dealing with equations, for absolute value equations, then when we're dealing with absolute value inequalities, we should get how many inequalities do you think?
2.
As a matter of fact, I want you to look over here at this problem. When we did this problem, notice how we could have actually written out 2 inequalities. We know 2 things about this. We know that, firstly, x had to be less than positive 4. You with me on that? But we also knew another one. Check this out. X had to be greater than -4. Didn't it? X had to be less than positive 4. X had to be greater than -4. We actually make up 2 inequalities. So when we do this absolute value inequality stuff, it is an absolute value, so we will have 2 inequalities. Okay, how do we do it? Look back over here at this first example, okay? When we make up our two inequalities, look what happens. Look, do you see that this one is really similar to the first absolute value equation we would have made up if this was an equal sign? If that was an equal sign, look at the board here real quick, folks. Don't change your problem, just watch up here. If that was an equal sign, we already have done this in this class, you'd have one of them equal to 4, and you'd have one of them equal to -4. Are you with me? Well, now, it's not an equation, it was less than. We have one of them less than 4. So we're going to make up one inequality by not changing any signs at all, just like you did with your equations. Are you seeing the similarities here? So make up one by not changing any signs. Now the second one's kind of important though. Look at the second one. Please watch the difference up here. When you made this first inequality, it was very much like making the first equation where you changed nothing. We said absolute value of x is less than 4, therefore first inequality is x is less than 4. Now if this were an equation, I'll go back to the equation, you'd have another x equal -4, if that were an equation, right? But look what we're doing. Since this is now an inequality, it's actually not x's, don't write this down, just watch. It's not x is less than -4, is it? X is less than -4, that would be these numbers. We know those didn't work. Because when we change them in absolute value, those all become positive and shift them over to that side. They're too big. That doesn't work. So what happened was, when we changed this number to a negative, we also had to change this sign to the opposite of what it was. Does that make sense to you? Hey, do you remember when you're solving your inequalities, what do you do when you multiply or divide by a negative? Y'all got to be with me on that. That's old school stuff. Are you with me that whenever you multiply or divide by a negative, you have to flip that inequality? True? Look what we're doing. We're essentially changing this sign. If we are going to change a sign, it's very much like multiplying or dividing by a negative. Here, did we change a sign? No, leave it the same. Here, are we changing the sign?
Yes.
Absolutely. What's got to happen to that inequality? It's got to flip. Okay, that's where we're getting that thing from. So, long story made short, we make two inequalities just like we did before. The first one, we do that without changing any signs. The second one, we change the sign of the number and we flip the inequality. The reason why we flip the inequality is because we're changing the sign of the number. Nudge your head if you're okay on that. Okay? So one without changing any signs. One by changing the sign. And here's the key point, key part of this, because we had that with the equations where you just change a sign. You must flip the inequality. That's an important part. Okay, raise your hand if you feel okay with this so far. You understood this example over here. That's good. Okay, so we know these are the numbers between -4 and 4. Or in other words, the numbers less than 4. And, we saw that word and, that's where that's coming from. And greater than -4. It's between there. That's where the and is, that crossover. Notice how we have a crossover here. Now I want to show you one thing. I'll make up the two equations. I want to show you something on both of these things, what we can do with our and or our absolute value inequalities. Check this out. Firstly, how many inequalities are we going to make out of this thing? Good. The first one is one where I'm not going to change anything about it, so can you tell me exactly what I'm going to have for my first one? X minus 2 and what?
Less than or equal to 1.
Perfect. First one, I don't change anything. It's just like I get rid of my absolute value. By the way, draw this one on the right side of your paper. Okay, do the first one on the right side. Trust me on this, it's going to be a lot easier for you if you do that. Put this on the right side of your paper. You with me? You'll see why in a little bit. Second one. Second one is going to be what now? Do I change x minus 2?
No.
Do I change the 1?
Yes.
What's the 1 become?
Negative 1.
Tell me the symbol I have to put in between there now. Is it less than or equal to or greater than or equal to?
Greater than.
Good, I have to flip that thing around. Why am I flipping that thing around?
Because you move negative to the other side.
Okay, so because I've changed this number to a negative, that means my inequality must flip around. Now, there's one cool thing that we can do. I want you to watch over here. Do you remember what I told you about and inequalities? By the way, this does mean and, just like it meant and over here. What I told you about and inequalities is that oftentimes we can mash them together and make one large inequality out of this thing. Remember me telling you that?
Yeah.
Check this out. I'm going to leave this one alone. This is why, by the way, you write this on the right-hand side of your page. I'm going to leave this one alone, but is it okay if I take this off the board and flip it around and put it back? Is that okay with you? So instead of x is greater than negative 4, I'm going to have x, I'm actually going to flip it around. Negative 4 less than x. Do those say the same thing to you? Okay, so I just flip this one around. This is the same as that. And x is less than 4. Hey, is this one of those cases where I can put them together?
Yep.
Negative 4 less than x, and x is less than 4. This means negative 4 is less than x is less than 4. Hey, does this picture look like this picture?
Yep.
It's exactly the same thing. In fact, we can do interval notation. This starts at negative 4. This goes to 4. We'll use parentheses because that is not equal to. But watch what we can do over here. This is kind of nice. We can do exactly the same thing here. I want you to follow along with me. Let's take this off the board. Let's flip it around. So instead of x minus 2 is greater than or equal to negative 1, I'm going to have negative 1 is what now? Is it going to be, if I'm taking this and flipping it, is it the same? Is it this way still?
No.
That wouldn't make sense. This way?
Yes.
X minus 2. And x minus 2 is less than or equal to 1. Okay, I need a head nod if you guys are okay on doing that. Or no, if you're not.
You don't change the x minus 2?
We don't have to. That's this part of it. The x minus 2, you don't have to do negative 2 plus x or anything. It really doesn't matter. What we're doing is we're just reversing sides here.
Oh.
That's all we're doing, okay? Does that make more sense to you guys? Okay, so I've just reversed this. I'm just reversing this one now. Yes, no, I get a no.
Yes. Yes.
Okay, so now we have negative 1 is less than or equal to x minus 2, and we also have x minus 2 is less than or equal to 1. This is the same situation, look at the board, as right here. Negative 4 is less than x is less than 4. It's just that instead of x, I have x minus 2. I can still mash those things together. Check this out. I can do negative 1 is less than or equal to x minus 2 is less than or equal to 1. I can put those things together and make a large compound inequality out of that. Have we seen stuff like this before?
Yeah.
This is why we did it, right? Because I knew we were going to get this situation with our absolute value inequalities. Hey, can you solve this in one step?
Yes.
Yeah, instead of dealing with two different inequalities, with your and or your less than or equal to or your less than absolute value inequalities, you can set this up like this and do it in one step. We have our three sections. How are you going to solve this, ladies and gentlemen? If we do that to all three sides, we will have 1 less than or equal to x less than or equal to 3. What's awesome about this is you can go directly to your interval notation. Where's this interval start, folks? Where's the interval end?
3.
Am I going to use brackets or parentheses here? Yeah, you got to be good on that. Make sure you're using brackets when you use brackets. Okay. Now this is kind of annoying to have to go through this whole thing every single time, right? I don't want to do that. I don't want to do that to you. Do you understand how you can go through this every single time, though? I want you to be with it on this. You understand where these two things are coming from, folks? This one, you don't change anything. This one, you change the sign, and you flip the inequality. Nod your head if you're okay with that. That's a must that you have to understand that. After this was some manipulation. I picked it off the board and I reversed it, just like I did over there. I noticed that these are exactly the same expression. My inequalities are facing the same way. That means I can mash them together and get this expression. Why am I doing that? Well, hey, that's easier to solve, right? All I have to do is add 2 to all 3 sides, and I'm done with my problem. Yes or no?
Yes.
Okay. Now, instead of doing this every time, we can understand that there's a shortcut with these type of inequalities. So here's what I need you to know. Pay attention up here. Anytime you have an absolute value with a less than or equal to, anytime you have a less than or equal to something, some number. Do you guys see that we'd be able to do this exactly the same way as these examples? Do you see that? Every time. If we have this symbol, we can write it ultimately as this. We had x minus 2 less than 1. We were able to, at the very end, write this as -1 less than x minus 2 less than 1. We could do that. We had absolute value of x less than 4, and we were able to write that as -4 less than x less than 4. We can do this every single time. So when you see a less than, it's going to signify an and inequality. Less than is and, or less than or equal to is and. And we can solve it this way. You know, a lot of people ask, they go, they say, Mr. Leonard, but wait a second. I thought you were going to have 2 inequalities, and one of them you don't flip the sign, but the other one you do. And then a lot of people ask me, but wait a second, aren't you not flipping the sign here? Aren't you not flipping the sign? And the answer is yes, you are. I want you to look very carefully at this. You do flip that inequality around. You guys are with me on that, right? But then you flip it back around when you change that. Does that make sense? So is this flipped around? The answer is yeah, it is. It's just you're writing it backwards, so it doesn't look that way. Is this one flipped around? Yes. But remember, we flipped it back when we wrote it in the reverse order. So are these ones written backwards of this? It actually is. It is, but you're flipping it back around. You write it in reverse. That's what makes it look like it's not.
Flip one side.
You don't flip this one at all. You do flip this one. However, when we're writing this in our shortcut method, we flip it back around. So it doesn't look like we're flipping it. So what this all leads to is this idea. We can do a nice shortcut here. If we have an absolute value that's less than or equal to some number, we can write this as negative. We're changing the sign. We're flipping the inequality, but we're flipping it back. X is less than A. Let's try a couple examples to really get the hang of this. Would you like to do that? Okay. Let's look at that. Okay, I need you to be rock solid on these 2 questions. First, does it fit the inequality, or does it fit the criteria for doing this for a shortcut? Does it fit the shortcut method? Or in other words, is it an and inequality?
Yes.
Yes, this means and. This means that you're going to have Our less than or less than equal to means our and. It fits a criteria because it is our less than. Are you with me on that? This is less than. In a little while, we're going to have greater than. It's not going to fit this. We're not going to be able to do the same thing. So you need to really kind of get that with the less than or less than or equal to, we can do this. If it's not this way, we cannot do this. Now you're going to agree with me on that. Okay. So since this fits our criteria, let's do what this shortcut says can do. What's the first thing we're going to write then in this case? What now?
Negative 3.
-3. So this says that I can write negative a, and put x in the middle of it. Basically is what that says. So I'm going to take my, in this case a is 3, so I'm going to put -3. Remember that, folks, what we're really doing is we're writing two inequalities, right? We really are. Look at, here's one of them, here's another. We're just mashing them together. So we still have to write two inequalities. We're still doing inequalities the same way. We're writing the positive of that number and the negative of that number. So we are still going to write -3, and we're going to write 3. What goes in the middle of those things?
4 plus 1.
If you're a little confused on this, pay attention up here, okay? Now, did you kind of buy into the fact that we need two inequalities? Did you buy into the fact that one of them's got to be positive, one's going to be negative? Same thing as you did with your equation on your homework. Did you follow me that one inequality we keep exactly the same? With the other one, we have to flip it around because we're changing the sign. Keep on in that. Now, I want you to watch what happens. We are going to make two inequalities here. Check this out. Ignore this for a second. Can you see that this is our first inequality? Oops. That's not our first one. That one is. Can you see that that's our first inequality? Okay, you ready? Now, ignore this side for a second. Can you see that I'm going to flip this around and make it, I would have made it going this way, right? But it would have been y plus 1 is greater than -3. True? Now, in order to get it to this form, I have to pick it off the board and flip it around. True? That's going to change us back to this way. That's why that's that direction. Does that make sense? So, am I making two inequalities when I do this? Yes, here's 1, here's 2. Am I changing the signs of the numbers? Yes, here it is. Am I writing this in the reverse order? Yes, I am, but I'm flipping it back around when I write this in this particular way. Raise your hand if you understand that. Good, you have to understand all those ideas, that I'm writing two inequalities, that one's positive, one's negative, and that I'm flipping the sign when I make that negative, flipping the inequality when I make that negative. But why do we do it this way? Well, this is a lot easier to solve than doing two inequalities, and it's already an interval notation. That's what we like. So when we do this problem, how do I get y by itself, folks?
Subtract 1.
Okay, let's do that. -4, I'm not going to change any inequalities. Y less than 2. That's beautiful. It's already set up in interval notation for me. Don't have to do anything else. All I have to do is tell where it starts, tell where it ends, use the appropriate symbols. We're good. Like it? Not too bad, right? Not too bad. You just have to remember one thing. With this less than or less than or equal to, you can do this. If this is not less than or less than or equal to, you cannot do this. Let's try one more together. I'll give you a couple to do on your own. I'll continue. Okay, write that one down and then take a good long look at it. Now, after you take a good long look at that, that should look kind of familiar to you from your homework. What's the first thing you might want to do here? Wait, say it again?
Subtract 2.
Why subtract 2? Aha. So the same rules apply. Same rules. Remember on your equations on your homework how you isolated the absolute value? You got it to the absolute value first before you made your two equations. Same thing happens here. You cannot go directly to this part if you do not have an absolute value all by itself. So just like with your equations, hey, isolate the absolute value. Isolate the absolute value first. So of course, yeah, in this case we're going to subtract 2. That's a really important point. If you don't do that, one side is going to be off. Your left side of your expression is going to be off. So we'll have the absolute value of 2x minus 5 less than or equal to 7. Okay, everybody up here, is our shortcut going to work for this problem? Is this an and inequality? Yes, look at that's the shortcut right there. That says it's less than or equal to. That means that instead of doing my two inequalities separately, I can make two inequalities together. Tell me how to start this. What number do I write first? Good. What symbol now? And again, last time I'm going to explain this. Even though this looks the same, we are writing it backwards. It's just we're writing it in the reverse order, so it flips it back around. Not sure if you're okay with that. Okay. And what goes in the middle?
2x.
Is less than or equal to what?
7.
Good. That we can solve pretty easily. How do we solve that? So add 5 pretty much everywhere. I know this is negative 2, less than or equal to 2x, less than or equal to 12. And our last step, ladies and gentlemen? Negative, do I flip the signs around if I divide by 2?
No.
It's not really division, it's division by a negative that would do that. So negative 1 less than or equal to x, less than or equal to 6. This is great. I want you to use the shortcut because this is already an interval notation practically for you. It's already done. You don't even have to draw a number line. Well, you can if you want to, but this is done for you. Do you see that, right? It's kind of nice. Where does it start?
Negative 1.
Where's it in? Brackets, parentheses.
Bracket.
Because we have those equal to, we've already done that stuff several times. That should be familiar to you. We can do that. Okay, give one of these a try on your own, would you? Get this homework passed around pretty quick. So we're noticing that we got to isolate the absolute value first before we start even working with that the absolute value in that inequality. So isolate that first. After that, notice that our shortcut is going to work. You got to notice that part of it. So first thing, what are you going to do?
Subtract 5.
Good. Did you also subtract 5? You didn't go directly to the shortcut, did you? Otherwise, the right side, this part would work out fine. This part would work out wrong, and you get only about a partial credit on that. You don't want to do that. So minus 5, we're going to get the absolute value of 3x minus 2 less than or equal to 4. Cool. Y'all made that far, right?
Yep.
Does a shortcut work?
Yep.
Yeah, it's less than or less than or equal to. That means we're going to take negative 4 less than or equal to 3x minus 2 less than or equal to 4. That's a nice shortcut that lets you solve it in just one step. That's great. After this, we're kind of home free, right? This is the easy part. We're going to add 2. Negative 2 is less than or equal to 3x, less than or equal to 6. We'll divide everything by 3. And get negative 2/3 less than or equal to x, less than or equal to 2. Would you please raise your hand if you made it that far? Good deal. Can you make it farther? Okay, I want to see you all ending with interval notation. That's what we're going to be doing in this class. So if we do, where does it start? Yeah, don't let the fraction intimidate you, right? All you have to do is write it down. Brackets, and you're done. Okay, folks, we should be pros at this. What's the first thing we're going to do on this problem? Add 1. Okay, so we'll do that. Add 1, add 1. Absolute value 5x, okay, plus 2/7 less than or equal to -3.
No solution.
Solution, no solution.
No solution.
Why?
The absolute value is already isolated.
Okay, absolute value is isolated, true. Whatever I plug in here, do you agree it's going to be positive?
Yes.
Is every positive number in the world ever less than a negative?
Yeah.
Is it ever less than? Is a positive ever less than or equal to a negative number?
No.
This cannot happen. Cannot happen. This would be no solution. That would be no solution. Now let me change the problem on you. Okay, watch for a second. What if this was no longer -1? This was now -6. Would there be a solution in this problem?
Yes.
Yes, because you add 6 to both sides. This would become a 2. And then you would go ahead and solve that. Do you see the difference on that? So don't just assume because that's a negative you have no solution. You really have to isolate your absolute value before you can do that. We're not going to finish that problem. I just wanted to show that to you. How many people feel pretty good about that shortcut that I just showed you? Now, of course, I told you the shortcut can't work every time. That means there's got to be something else that we can do with these things. And that comes down to, instead of dealing with a less than or equal to, what if I have a greater than or a greater than or equal to? Like this. Like that. Now I want you to think of some numbers that are going to work in this thing. Give me one number that's going to work here.
3.
3, okay, go for the obvious one, that's awesome, because it's equal to, you can get 3. No problems there. What else? 4, let's check 4. What's the absolute value of 4? Is that bigger than 3?
Yeah.
What else?
Infinity.
Infinity works. Do you know what infinity is?
No.
I haven't either. I wish I did. Awesome. 4 works, 5 works, 6 works, 7 works, 8 works, right? Because all those absolute values make it bigger. How about -2?
No.
Why not?
No.
How about 2?
No.
How about 0?
No.
-1?
No.
-3?
No.
Why -3?
Oh, yes.
Yes, that works. How about -4?
Yes.
-5? Remember, with a negative number, -4, what's the absolute value of -4?
4.
It changed it positive. So on our graph, here's what you said. You said -3 worked. You said 3 worked. Do these numbers in here work at all? We
No.
just asked this. Did
No.
none of these work? Did these numbers work? These numbers also worked. True? Does that look familiar to you? Remember? We did that? This is your or. The other one, this is and, for sure. This is your or. That's why we covered both those things. This is the part where we don't have anything in there. We have this. We have this. This set of numbers or this set of numbers will work. Let's look at an example here. Okay, here's those questions I'm going to ask you again. First thing, is our shortcut going to work on this problem?
No.
Does it look like this one?
No.
Heck no, no way. This is way different. This is not less than or less than or equal to. This is greater than or equal to. What's actually kind of nice about this, there is no shortcut here. There's no shortcut. And it's kind of nice because you don't have to manipulate this at all. All you do is you make up your two inequalities and you solve them. Our shortcut said we could mash things together, right? Because they intersected. Here, these things, they don't intersect. We can't mash them together, therefore there's no shortcut. Nudge your head if you're with me. Shortcut. No shortcut. Okay, no shortcut there. So, when we do this, we're going to make our two inequalities up. The first one, do we change anything about the first inequality?
No.
We're just going to essentially drop these signs. Again, put this to the right of your paper. Trust me on this. X plus 2 is greater than 4. We don't change anything about that. Let's do the other one. What's the other one that I'm talking about? What do we have to write down? Okay, so tell me exactly what I need to write. X plus 2 and then less than what now? Perfect. Notice how we're changing the sign of the number and we're flipping the sign. Raise your hand if you're okay with that. Good, that's fantastic. That's exactly what we need to be right now. There is no shortcut. Look how the signs are facing different ways. Even if I reverse them, they'd be facing the wrong way. They'd be actually going from a negative to a positive. The signs would be right, but the expression would not be. Okay, it's say you have a number that's less than a negative and at the same time bigger than a positive. And that can't work. That expression would be meaningless. You cannot do the shortcut with a greater than or a greater than or equal to. Are you with me on that? You cannot do it. All you can do is write your two inequalities. These are talking about an OR. These are OR inequalities in the middle. And then solve each one. So what we're doing here, you're still going to make two inequalities. No shortcut. Here's the whole idea. Here's actually what we saw here. What we saw here is that we had x's greater than or equal to 3, and we had x's less than or equal to negative 3. That's what we had. We had one exactly the same. We had one by changing the sign of the number and flipping that sign around. That gave us this graph. Look at how these graphs match up. Do you see that? They do match. One's exactly the same. One I changed the sign and flipped my inequality, and it gave us this portion of our graph. That's why we have to do that. So for any absolute value of x is greater than or greater than or equal to a, we're going to do x is greater than a, x is less than negative a. And that's what we're doing in our case right here. And we're going to solve each one. So let's solve this. How do you solve the right one? X is greater than 2. How about this one? X is less than negative 6. So far so good? Hey, here's why, by the way, I had you write the first one on the right-hand side. Because if you do that, check it out. Most times, 95% of the time, when you do your number line, it's now in order. See how it's in order now? You don't have to switch things around. That makes it kind of nice, right? So we're going to have our negative 6, our positive 2. It's already in order. Guess what? This is an OR inequality, right? OR 99% of the time, 95% of the time, goes like this. That's what it does. So if we have x bigger than 2, we know we're going that way. If we have x less than or equal to negative 6, we're going that way. We've done this a lot. That's why I'm kind of going quickly through it. We should have mastered this concept at this point. Can you do your interval notation from here?
Yes.
Where does this interval start? Wait, negative to where? Good. Parentheses? Parentheses. What goes in the middle of our two values? Two segments here. We go 2 to infinity. We're done. So here's our idea. Idea is make your two inequalities. One positive, one negative for the sign of the second one, the inequality of the second one. Solve both of them down. Chances are you're going to get that. That's most likely what's going to happen. Let's try a few more. I'll give you one to do on your own as I'm erasing some stuff over there, and then we'll call it a day. There you go. So work on that one. If you finish that one and you're feeling pretty good about it, try this one. We'll take about one more minute to see if we can wrap up that problem. If you finish that one first, do the second one. Okay, let's work on the first one together. Hey, does a shortcut work for this problem? Did y'all shake your head? Should I even be asking about the shortcut yet?
No.
What's the first thing you should be doing?
Subtract 11.
How many will subtract 11 right off the bat? Good, that's fantastic. You need to be doing that. So subtracting 11, greater than or equal to how much?
Negative 2.
Oh, whoa. That's weird. What do we have here?
No solution.
I want you to think about it for a second. I want you to think about it for a second.
Oh, never mind.
Think about it for a second. What's absolute value do?
2 positive. Makes it positive.
No matter what, it makes it positive, right? No matter what. No matter what, it makes a number positive. Is a positive number ever bigger than a negative number?
Yes.
Is a positive number always bigger than a negative number?
Yes.
You agree that's a positive number?
Yes.
That's bigger than a negative number, right? Always. Always bigger than a negative number. This is all solutions. This is infinite solutions, negative infinity to infinity. This is one of those ones where your or would cross over, right? You can't solve this. It doesn't make sense to actually write out the inequality. But if you have a positive greater than a negative, that's true all the time. No matter what you plug in. Try any number, okay? Give me, it's just some crazy number.
1.
1's a crazy number. Crazy. How about negative 53? Add 1 to negative 53, what do you get?
Negative 52.
Take the absolute value of negative 52, what do you get?
52.
Do you see how when you take the absolute values, you become positive? Is that greater than negative 2? All the time, no matter what you plug in, and that's what this says. No matter what I plug in, that's always true. Okay, now we can try this one, all right? Let's all work on this one together. What's the first thing we do on this problem? Sorry, I kind of threw a curveball at you on that one. You're like, wait a second, Leonard, this is too easy, no solution. Well, actually, it's all solutions. How about this one? What do we do here?
Subtract 5, isolate absolute value.
Good, let's all work on this together. If you participate up here, we get the absolute value of 4x plus 3 is greater than 5. Y'all need to isolate the absolute value first. That's the first thing you do in every single one of these problems in section 9.2 or 9.3. Now, is my shortcut going to work here? You need to know that. Is it going to work or not?
No.
No. It works if it's this way. It does not work if it's this way. The first inequality that we're going to write is 4x plus 3 greater than 5. Without changing anything, someone on the right-hand side of the room, tell me my second inequality. What do I write out? Is what now? Wait, is it going to be greater than or less than?
Less than.
I'm hearing both people. I'm hearing people say
Less than.
we have to switch that around. You have to switch it. You change the sign, you flip the inequality. Folks, on an or, on this type of inequality, look at your symbols here. They will be facing different ways. Okay, they're going to be facing the wrong ways. Well, the correct ways, but different ways, not the same way. Subtract 3. We get 4x is greater than 2. Divide by 4. Don't change anything around. Greater than 1/2. Subtract 3. 4x is less than negative 8. Divide by 4. X is less than negative 2. Can you graph this on a number line?
Yeah.
Yes.
Do that. Let's do that together. Where does it start?
Negative 2.
Notice if you do this in the correct order, it's already there for you. Negative 2, 1/2. Let's do this one first. Folks, should we go up and to the left or up and to the right
Up to the
here?
left.
And on this one, do we go up and to the left and up and to the right? Which one?
Right.
Can you graph this with an interval notation? Or do interval notation with that?
Yep. Negative 3 is negative 2.
I know parentheses go around my infinities. Am I going to be using parentheses or brackets for my negative 2 and my 1/2? It's as good as we can do. On a show of hands, somebody feel okay with that example? Yeah, good. How about this one? What are you going to do first?
Add
Add
5.
5.
If we add 5, we get x minus 2 minus 3 greater than 3. What now?
Translation.
2 inequalities. First one we do without changing anything. Second one we do by changing the sign and the inequality. It's this part right there. That's the important part. I just want to make sure you don't get stuck on these fractions again. Some people have kind of made some mistakes in their homework with this stuff. When you're doing this, try adding the 3 first, okay? And get x over 2, in this case is less than 0, x over 2 is greater than 6. Now multiply by 2. That way you don't make any mistakes on that. If we do, we get x is less than 0, we get x is greater than 12. With our, I'm not going to do the number line, well I guess I will. Here's 0, 12. It's so easy, it's so fast, it doesn't really matter. Negative infinity to 0. We use some parentheses there because we don't have any equal sign. Union, 12 to infinity. And that's our answer. Hey, do you guys feel okay about this inequality stuff? The absolute value inequalities? We know essentially we're making 2 equations. With our and, with the ones facing this way, we make the compound inequality, we do it in one step. With the or, the ones facing this way, the ones that are going to go like this, we make 2 inequalities using the steps that we've just talked about, not changing anything, changing both the inequality and the sign, solve them both. Put everything in interval notation when you finish.